Hello, I'm Chad Kinney, and this presentation is about how to use a semi-logarithmic graph. So this graph is semi-logarithmic because only one axis is spaced logarithmically, which is why the horizontal lines get closer and closer together as you move from the bottom up. You see it starts from here to here, it's fairly long spaced, and then it gets shorter, and the space gets shorter, and the space gets shorter. The lines get closer and closer together until you get to the next cycle, and the pattern repeats itself where they get closer and closer together. Now the other axis down here is linearly spaced in equal intervals, and this is what people are often used to seeing. So the spaces are from 0 to 1 are the same as they are from 1 to 2, and from 2 to 3, and from 3 to 4. Notice the lines don't get closer and closer together. They're spread apart in equal intervals. So a logarithmic scale is ideal for compressing a large range of data into a relatively small space without having to sacrifice much in the way of seeing variability in the data. That is, one can still detect relatively small variations in the values of data points in a set, even though a large range of data is on the same piece of paper. Moreover, the distances on a logarithmic axis are proportionally spaced. So for example, the distance between 1 and 2 is the same distance as between 100 and 200. You see, from 1 to 2, notice this space, and then look at the space from 100 to 200. The exact same distance. Also, the distance between 10 and 20 is the exact same, and below 0.1 to 0.2 is the same. As the horizontal lines get closer and closer together, the proportion changes. And this can be seen in an example of, again, going from 1 to 2. That's a greater increase than going from, say, 9 up here to 10. So when you go from 1 and then you add one more to get to 2, you've increased by 100%. So the distance is fairly great. But if you've already got 9 and then you add one more, well, you're not adding as much now. It's only about an 11% increase. So you see the distance between 9 and 10 is relatively small compared to 1 and 2. For these reasons and more, some have chosen a semi-log display as a standard for displaying behavioral data. So here's a rhyme to learn. The numbers with a 1, you can see all the numbers with a 1 that are pointed at with the green lines. So the numbers with a 1 from low to high, so there's 7 of them. Here we go from low. They're the only ones with a 1 in them on this axis. So the numbers with a 1 from low to high are what you count from and what you count by. Hopefully you're going to say by. Okay, so if you apply this rhyme, the numbers with a 1 from low to high are what you count from and what you count by. You look at the very bottom, down low, and you see a number with a 1 in it, and it's 0.001. And this tells you what to count from and by. So you count from 0.001 by 0.001s. So say the value of the red line out loud. Here's the red line. You can say it and it'll appear right here in this blue box. So say the number of that red line out loud. Okay. And did you say 0.001? Hopefully you did. Let's try another one. So we move the red line up to the next line up, so going from low to high. So 0.001 plus 0.001 gives you 0.002. See, because we're going from 0.001 by 0.001s. So if you're at 0.002 and we go the next line up, what's the value of that line? Say it out loud. 0.003. And the next line up is 0.004. And the next line up is already labeled for you, so you can see it's 0.005. What about the next line? 0.006. And the next line? 0.007. And the next line? 0.008. And the next line? 0.009. And then 0.009 plus 0.001 gives you 0.01, also labeled for you. And now we're at the next cycle. This is a number with a 1 in it, so it's going to tell us what to count from and by from low to high. So from 0.01 by 0.01s, what's the next line up? 0.02, and the line up after that, 0.03, and then you have 0.04, and then this one's labeled 0.05, and this one 0.06. Next, 0.07, next, 0.08, then you have 0.09, and then you have 0.09 plus 0.01 gives you 0.1, obviously labeled. And once again, you are at a number with a 1 in it, and so from low to high, it'll tell you what to count from and by. So you count from 0.1 by 0.1s. Next line up is 0.2, next line up 0.3, next line 0.4, then you have 0.5, then you have 0.6, next 0.7, then you have 0.8 and 0.9, and 0.9 plus 0.1 gives you 1. And once again, we are at a number with a 1 in it. Actually, this is 1, so from low to high, it'll tell you what to count from and by. So the next line up is 2. Now, I bet you see a pattern now. So let's just finish the rest of these out a little more quickly. 2 is where the red line is at now. The next line up would be 3, then 4, then 5 as labeled, 6, 7, 8, 9, and 10. And once again, we're at a number with a 1 in it, and it tells us what to count from and by from low to high. So from 10 by 10s, the next line up is, see if you can say this one out loud. Did you say 20? If you did, you got it right. If you said 11, just remember the number with a 1 from low to high is what you count from and what you count by. So 10 by 10. So 10, 20, the next line up is 30, the next line up is 40, next one's labeled for you 50, and then it goes 60, and you probably see the pattern, 70, 80, 90, 100. Let's try another one. Alright, we're going to skip up ahead, see if you can get this one. Did you say 200? If you did, nice job, because you count from 100 by 100s as the rhyme would direct you to. The numbers with the 1 from low to high are what you count from or what you count by. So you count by 100s from 100. And the next lines up after 200 are 300, 400, 500s labeled for you all the way up to 1,000. Okay, so let's put this into practice. We're going to say the values of actual dots from left to right. This could be, say, the value of some behavior that you have counted, or at least some dimension of behavior that you've counted, whether it's rate or the duration or something. But what would these values be from left to right? So the first value here you can see I've marked with a blue box there. So what's the value of the dot? If you said 10, you're all over it. Nice job. Now about the next one. 40 is correct. And the next one, well, that one's 1. That's pretty easy. How about this one? 0.2 is the answer. And the next one? 0.005. That one's labeled sort of. And the next one? 0.04. Not 0.4, but 0.04, because you're counting from the number with the 1 from low to high. So 0.01 by 0.01 would be 0.01, 0.02, 0.03, 0.04. The next one, 0.02. Good. And the next one, 0.6. 0.6. And how about that last one up there? This one would be 300. So hopefully you got those right. Let's go on to something a little bit more advanced. So in this one, we're going to say the approximate values of the dots from left to right. And you can see in the very first example that we have, the dot is not actually on a line that's horizontal. So how do you say it? Well, it's in between the 10 line and the 20 line. It's about halfway between. So what's halfway between 10 and 20? If you said 15, you've got it. How about this one? 150. And this one? 25. What about this one? 0.15, because it's between 0.1 and 0.2, so halfway between is 0.15. How about this one? Well, that one's labeled for you, 0.005. Here, 0.015, because it's between 0.01 and 0.02. How about the next one? 0.025 is the answer. Okay, so maybe you're seeing the pattern now. I hope you are. You might also notice the proportionality of these things. So notice that 0.025, look at the distance between it and its one line. See the distance? Remember that. And then now look up here to the 25 mark. See the distance between its one line, the 10, and the 25? It's the same. It's proportional. Okay, the distance is proportional. You'll notice the same thing with the 1.5. So 15, the distance between it and its one line is pretty short there. Also, it's the same distance between the 0.15, okay, and also 0.015. Oh, and I almost forgot, 150 is the same distance between its one line. So that's the proportionality of this logarithmic axis. Okay, and that's it. So the graph shown here was created from a simple Excel program. It's similar to both the standard acceleration chart. You can see this website here for more information on the standard acceleration chart. And it's also similar to the standard behavior graph. And you can see this website here for information on the standard behavior graph.